Good morning. I'm from the federal government, and I'm here to help you. I had to say that. I've never said it before, so I had to say it at least once. Good morning, and I'm really, truly delighted to be here. It's a great pleasure. Thank you for the invitation. And I am here to learn. I am new to the field of energy, but not to government. I'm an accidental government worker. I joined the government about 12 years ago to spend a year, and here I am, 12 years later, still working. What I wanted to share with you today, some of the focus areas of our newly named Advanced Manufacturing Office. This is a new thrust within the Department of Energy. And you will see, and hopefully those of you that were able to watch the President's State of the Union address the other day, you probably heard the word manufacturing a few times in there. I counted 16, I think. But this underscores the importance of manufacturing that the federal government sees both at a strategic and tactical level. So let me just briefly talk at that level for a moment. Strategically, manufacturing and energy efficiency in manufacturing and the renewable energy industry are critical to the United States and to the world. I mean, we have to worry about the melting of the ice caps, the climate change, and so on. And that's a strategic role that we have to worry about. We also have to worry about imports of petroleum products and other critical materials like that. Tactically, though, it's all about being efficient, productive, and creating and manufacturing high-quality goods that people want to buy. This is the strength of the country. It's hard to imagine that the country will remain strong and prosperous selling hamburgers to each other. We have to do something. We have to manufacture products. And the manufacturing of those products has to be timely, efficient, low cost to compete in the global world. All of you are global companies, or most of you are global companies here with operations throughout the world. And it's not our intention to sort of stop you from doing that. We just want you to be the best in the world. And there may be some things that the federal government can indeed do to help with that idea. So our mission statement within the office, it really talks to the nation's goals as articulated by the President and Congress, but then it really cascades into specific projects. And those of you that know me know that one of the most important questions that I asked of my staff and of everybody that works with me is, what will you do? What will you actually do? I often get frustrated by people that talk about, we coordinate, we facilitate, but what does that mean? What will you do when you walk into your office that morning? So what you will see from us is at the bottom, specific projects that address some technological development, some technological breakthrough, or some market barrier, trying to overcome some market barriers. So we're going to talk about specifics in my program rather than generalities. And I really want you to sort of take the message away from us. Why is manufacturing important? Well, it employs most of us engineers. As you can see, even in this down economy, 11% of our GDP comes from manufacturing. It's actually increased about 12, I think, most recently, and employs 60% of engineers and scientists. That's us. That's people like you and I. But it also consumes 30% of all the energy consumption in the United States. So we need to fix that problem too. And the question that I often ask is, are there fundamental things that we can do that are pervasive, that can help everybody in order to achieve both a reduction in consumption of energy and make us more competitive? And we try to do this, or we will try to do this in this new office by two methods. We're going to try to invest in some technologies and help, and I'll go through that a little bit. But I also want to share with you that we will invest in technology deployment. And in the second area, it is really all about technologies that we know about. Maybe the technologies that you have right now in your midst right now. We just want to make those abundantly clear to people, to all 300,000 factories in the United States. We want technology deployment where the technical risk is essentially zero, because these are technologies that have been done before. Now, there will be other technologies which will have technical risk, and we'll invest in those too. But we want to help facilitate those. And we will do those types of outreach efforts through training programs. I was very pleased to hear the emphasis from Diane and the other folks this morning on training and people, from training, from infrastructure development, as well as technology. Some of you may have interacted with the office with a program before it became the Advanced Manufacturing Office. And as you know, within the Dept.Of Energy, we have a number of different programs, solar, wind, and so on. And we will work with those programs for specific projects where we will take the manufacturing aspects and the control, process control of those programs under our wing, and we will focus in the efforts in specific projects with specific outcomes. And you will see these are in the mode of DARPA. There will be 3 to 4 year programs, very targeted, very milestone driven, and very much on a commercial basis. We're going to be using new instruments of procurement that do not necessarily require federal acquisition regulations. We will engage with other transactions authority. Those are akin to commercial contracts, essentially commercial, so you don't have to have a government accounting system. It will be based on unequivocal payment. Our contribution to this, our investments will be based on clearly articulated milestones. You deliver something, not a report, but something, some major milestone, you build something, we will pay. You don't deliver, we don't pay. You know, this is the way it is. We're going to become more like a commercial entity. Now, there are some rules and regulations, but for the most part, you will find that these agreements are really much closer to commercial contracts. And we will work with other entities within the USG, the Department of Defense, and my former DARPA folks, and so on. So this is some of the changes that are coming along. And let me give you a specific example of the way we're going to work. We have identified the 3 sort of domains that we're going to work on. The next generation materials, next generation manufacturing processes, and here I want to emphasize control architectures, and so on, and technology deployment, and this is the part that I talked about earlier, where this is the application of technologies that we know about already. So there's no technical risk in the sort of the green box, at least on my monitor. I don't know what it is. But there is some technical risk in the other technologies. And as I was talking at the table a little earlier today, our involvement in the sort of the new generation materials and manufacturing processes, it's all about manufacturing, demonstrating energy efficient technologies at a convincing scale. That's really important to me. In a production relevant environment. manufacturing pertinent. Those kinds of phrases are very important to me. And it is a lot more about than just making a widget and saying, here is a solar panel, here is a widget, and we've demonstrated it. It's about getting enough information to make an investment decision regarding that product or that process. So the outcome of our projects should be some decision that you make to either invest or not to invest in a process or a selection. So it's not just we will make a demo and that's it. I talk to Secretary Steve Chu occasionally, and I, as you know, a Nobel laureate, I tell him, sir, I said, you know, people win the Nobel Prize for the best, for the highest, the most, and so on and so on. I said, I worry about the -3 sigma line. I worry about the -6 sigma line. I worry about how to bring the bottom distribution up, because that's what you sell. What you sell is the quality, the reproducible quality. What is the highest 3 sigma line that I can give you? That's what I need to work on. That's what we will work on. We will work on those kinds of projects where we're going to try to use process control, sensors, you know, whether you like expert systems, AI, fuzzy logic, I don't really care. Whatever the approach is, we now have the technology with the connectivity, the wireless communications, and so on. I'm not going to touch that. We've obviously heard a lot about that this morning. But the infrastructure is now there, both in communications, sensors, and controls, to make it happen. And you know, what we need is a commitment for reducing our energy footprint and making us the low-cost, high-quality manufacturers. And quite frankly, it would not be useful to be the most efficient but the most expensive. You know, we have to deliver the efficiency at a cost that people are willing to pay. And that's what we will do. And we have any number of approaches to doing this. I want to also share with you that we're not going to invest in 6.1 or in a very basic science technology. We have other organizations that do that. Our own Office of Science does that, National Science Foundation. This is not a science project. This is about making things. I will not necessarily go into everything that I could in the interest of time, but I just really want to sort of leave you with some thoughts, what I wanted to get out of this meeting. I want to really get some end-user engagement. I would like to learn. We do not create these thrusts and these initiatives by sitting inside the Forrester building, inside the Washington Beltway, and imagining what we should be doing. We do those initiatives, and we come up and we sponsor those initiatives through engagement with industry and you all. And it is really important that you engage with us. We also engage with states and utilities. These are other stakeholders. Manufacturing is local. Manufacturing happens in states and localities. So we're very interested in expanding our interactions with the states. Let me finish with another anecdote. One of my favorite sayings has been recently, I want to defeat the tyranny of the periodic table. So I'm a materials scientist, materials engineer, and you know, the periodic table, you know, 108, 118, whatever the number is of elements today, whichever they've discovered today, you know, that's what we have. Well, that's not true. What is really, whether the options with respect to our ability to make things is, look at a piece of clothing you have, for example. Look at this tie. It has a lot of different designs. The topology, the arrangement is a major capability. And once you add that, the options are endless. But the arrangement has to be placed, the control and the reproducibility and the quality and the assurance and the, if you wish, the prognosis, the predictive capability of that function is very important. I'll make it real for you. Our soldiers, Marines, and our warriors all wear bulletproof flak jackets. I've been part of developing that. And you know, they essentially contain two elements. This is not classified. Two elements. They contain a ceramic, a hard material, and Kevlar or something like this at the back. And with that vest, you can come up to me at point blank range, shoot me with a Magnum 44, and I'll get a big bruise, but I won't die. But I can take that flak jacket and just turn it the other way around. Wear it again, but now Kevlar is facing you and the ceramic is facing me. You shoot me, and I die immediately. Topology matters. Arrangement matters. Okay? So those things are really important when we start to make and produce things. We have a lot of flexibility to make things, and people that design products have a lot of flexibility. What we need to give them are the tools and the control strategies and the sensors and so on to make those products reliably, high quality, at low cost and efficiently. Controls, controls, controls. Sensors, sensors, sensors. Knowledge, knowledge, knowledge. It's what you know about that material that product that makes it valuable. Diane's aircraft, the value is not just the materials and the design, is what Boeing can say about it. Boeing can say that that aircraft will fly for 32 years. It could log so many hours with this reliability. That's the value. The value is not the design. There's some in that. There's some in materials. But that's a cost. The value to the customer is what you can say about that product. And you could do that with good process control and good knowledge and good science. And that kind of program and those kinds of attributes are the way I believe that manufacturing will be in the future and how we are going to compete in a global world. Thank you.